we'll go to introductions properly in a minute. So the agenda, we're going to give you a bit of background about us, explain where Ely is for those of you that get a bit funny on the wrong side of the river. We're going to tell you how the programme was structured, because it's very much a programme. This presentation was given the title Ely Remodelling, but it's actually slightly different. What we've done in Ely, but what we've done dozens of miles away from Ely as well, and then the overall scheme impacts, and then summarise where we are. So a little bit about me. I've done most of this already. I'm not a railway engineer by training. Got a degree in car design. I made it work anyway. I've worked in lots of different bits of the rail industry, but the longest stint so far is Thameslink. I spent quite a while in development, which is where I've seen you before, so Croydon, things like that. And like I said, 3.5 years at WSP. James, over to you.
Yes, hello. So yeah, I'm James Hudson. So I've got a degree in civil engineering, worked in various places, graduates, NR graduate from 2008. I was on that bridge with Balfour Beatty, Hittington Steel for a year, which was nice. But mostly I've worked in projects since then in the Anglia region, mostly doing stations and other multidisciplinary stuff. I left the project world earlier this year to join structures maintenance. And yes, it's very different to projects. That's enough about me. Let's go on to the interesting stuff.
Should probably apologise at this moment for the colour changing slides.
Yeah,
we had some last minute edits, shall we say. The edits are in red.
And yes, didn't have time to change it back. Yes, so the Ely scheme, its outline business case gave a return of over £4 for every £1 invested. Its aim and benefits are reducing emissions, improving transport, growing and levelling up the economy, as it's a key corridor for freight between Felixstowe and East Midlands in the north, supporting global Britain, boosting passenger service as well, because it's on the main line between Kings Lynn and London. And yes, it's don't know what's in the benefit slide, but it's important to note that this is pending a DfT funding decision.
So we are a long way north of Southern here. We're even 12 miles north of Cambridge, and when you go up there on the train, suddenly it's even a different world. Everything is flat, windy and cold. That's really important. It is flat. It is very flat. It's very low. You'll see actually that the darkest blue scale there is below sea level, and it's weird. You see this ridge on the horizon. You walk up to it, and that's the river, and it's above you. It's a very, very strange area.
It's the reason it's called the Isle of Ely.
Yeah. It's an ancient city. So the Isle of Ely was the last place to be conquered by William the Conqueror, if you're taking notes. And then he built a massive cathedral there to put people in their place. But it's got some really old institutions there. There's actually some very ancient landowners that we've had to deal with in this process. So where does Ely sit in the rail network? Right in the middle of North Anglia is how we've defined it. So the Ely core is in that area, and we're going to take you through a bit more detail on the Ely core. But the programme actually covers everything within the outer dashed red line there. And that is primarily because that's the primary freight route that avoids London from the port of Felixstowe, and the aspirations to significantly increase the number of trains that flow on that route. I like to call this the blockbuster diagram. This is these are the projects that are moving in the North Anglia area at the moment. So basically the darker blue are the projects that are on the ground at the moment. Greys and light blues are very much younger in their gestation. Personally, I'm also working on Sizewell C, the magenta one off to the right. Doesn't actually really fit in here, but it's another moving part in the area. And Kingsdyke bypass has recently opened, so one fewer level crossing on the Anglia patch. The ones that are really critical to our programme are the ones that are remaining on the screen, and we will come back to them in various levels of detail as we go. So you can really see there's a lot of moving parts in North Anglia. This is the portfolio. We're going to tell you now about the programme, and then there are lots of projects within the programme. Okay, over to you, James.
So taking it a few steps back, Ely Area Capacity Enhancement Project came about as it was recognised that it needed a whole area programme scheme to deliver the benefits that were required. Previously to this, there'd been schemes at Ely North Junction, there'd been Ely to Soane doubling, there'd been Ely Dock Junction, and all of these were put in place to try and deliver and improve the train services through Ely. But on their own, they couldn't do it. So it was recognised that it's not just a rail system in the core problem. As Peter said, it was entirely in that dashed area. But if you want to increase the capacity in that area, you have to do everything in there and sort a lot of things out. So say it's Ely is the limiting. Sorry, it's a pinch point. Change my words there. And its key constraints are the layout itself around Ely Station and Ely North Junction. There are permanent speed restrictions that have been there since the early 90s over two major structures over the Ouse River. There's double blocking issues due to the junction layout at Ely North Junction and its relationship to level crossings. And then there's the level crossings themselves in the whole of that dashed area. As Peter said, it's very flat. So there are a lot of level crossings through that area.
Was the number 180?
100 around that.
180 made it onto the list that we've had to assess. It's a huge number.
And you can imagine if, as the scheme is to increase trains over all of those level crossings, the risk will go up. And it was about managing that risk. And also, yes, surprise, surprise, a lot of assets are life expired. And this is the desired outcome. This was the S1 timetable, which is 9 trains per hour into Ely Station, but using 10 paths because we have a reversing train that comes from Peterborough direction, comes into Ely and turns around, goes to Norwich. So it was that caused lots of confusion how we were writing that and how we established the number of train paths used over a section. And this just shows the amount of conflicting movements we've got between the main freight flows between Felixstowe and the Midlands and the North. These lines going through the middle, and you can see that we've got the passengers conflicting with those trying to cross over these paths, or vice versa, going through the core section. More trains, so it's additionally it's 2.5 trains per hour on top of what's there originally, plus 6 freight trains initially, but a provision for more and provision for future passenger services. So this is a photo of Ely North Junction. I think it's okay. And as I said, this, as you can see from this picture, is very site constrained. There's a nice freight yard as well, just to add into the mix. It's just an example of the station area is also very constrained. And again, Fenland ground conditions. It's lots of peat through there, so any earthworks we put in are very complicated to do.
Buildings shake when a lorry goes past. It's weird. It's really, really weird. We were standing in the village hall and the floor was just going like that.
Actually, and the off-track team like wooden fence posts around there rather than concrete because they're easy to put back up once they've fallen down. Oh yes, and it was rationalised in the 1990s as part of, I think, part of electrification. So the solution to this is a major capacity enhancement in that core area and level crossing interventions and structures renewals, resulting in speed improvements through the core and headway improvements to achieve that capacity for the 10-11 trains per hour through the core. And we will need a transport and works act order in order to deliver this.
So the reason that we could do this presentation at relatively short notice is that I actually gave this a version of this presentation internally. So this is why we've got a few legacy slides from there. So WSP have been involved for about 4 years now. Started off as a Grip 2 into Grip 3 contract for the Ely core, which for whatever reason, it didn't quite cover the programme, going back to the project versus programme argument again. So there was a second contract let for the wider level crossings, and those two contracts were effectively merged together. And if that wasn't enough, they then said, that as in the Network Rail project team then said, we also need you to look at another line, because even though we've thought of it as a programme, we've not looked at this leg of the programme. So can you do that as well? So they're the moving parts of the programme and the level of detail that we've gone to. On top of that, the sponsor team recognised that the portfolio wasn't being fully managed, fully understood the interfaces between them. So we also stepped in and helped them define some of the interfaces, and that blockbuster diagram was one of our outputs. Moving into Ely itself, this is a shot of Ely Dock Junction. So it's the Soham single running off to the bottom right, and you've got Cambridge on your left shoulder, and then Ely Station just behind the trees there. So what do we need to do at the station? As you've seen from the picture, that's where two of the lines join. There used to be a third, but that's long gone. At the moment, we can just about regulate freight trains, but only if they're the right length and they've come from the right direction. So that's a need if we're going to enhance freight services. Some routes you pay a really hefty time penalty to go through, and that's on top of the slow speed as well. So it's slow or slower. So this is what it looks like in plan view. So the station is there. You've got Dock Junction in the just to the left of centre, which combines the lines from Cambridge and Soham, and then off to the right we'll go up to Ely North Junction in a minute. I think it's really important. It doesn't really stand out on here unless I do this. That's the river that runs through the area. And the river is certainly between, the river banks are the highest thing, that the river banks are well above the Cambridge main lines. So the river bank is kind of the order of 4 metres above ordnance datum, whereas the rail lines are about 2.5 metres. So it's, and they're on an embankment themselves. So we're trapped. The station is trapped. You've got Dock Junction, which can't really move, and then you've got the river bridge immediately to the north of the station. There's also an underpass. The level crossing was closed 2018, 2019. So you can still see the scar of the level crossing there, but that's now gone.
It used to be the most hit bridge in the country, Stony, not Stony. What's its name?
Stuntly Road.
Until they built the new underpass. That allowed us to close it. Top 10 now.
And I think we've got the top one coming. Yeah. So what are we going to do? This is the current plan, is to rebuild the freight loops and extend them towards Soham. That would give you regulation for two 775-metre freight trains at a reasonable speed. And we essentially rebuild the entirety of the S&C layout to increase the capability of the network. We came up with two principal options. One was an extra span at Cutter Bridge, which we'll show you in a minute. It performed better, but didn't perform well enough that you could justify the additional cost, we think. In all cases, land is required. So we need a Transport and Works Act for a variety of reasons, but land is a key driver there. We're going to have to take a little detour from Permanent Way for a minute, but James is a structures engineer, so we'll give him his moment.
The most important things in the whole scheme. So right now, as you saw from that overview of Ely, there's Cutter Bridge, the top one on this picture, lovely truss, and right next to the station. So that limits the amount of space and what you can do with your layout, both horizontally and vertically. And this has got a 20-mile-an-hour speed restriction for freight going over it. So you can imagine that, well, actually, along with Common Muck Hill Bridge as well, that has a 20-mile-an-hour speed restriction for freight over it. So this is sat right in the middle of the core, whereas our principal traffic will go, and that is limiting the speed and therefore the capacity that the trains can go over it. It's not as much as an issue for passenger because most of them, if not all, stop at Ely, so they're slowing down anyway and speeding up, but it's still a constraint. Yes, these are not very strong bridges. The Cutter Bridge especially needs some work on it in this control period. And we were hoping to combine this scheme with the renewals that it needs. So yes, so proposals was to replace both of those structures with brand new bridges. The abutments on the existing structures are showing signs of failure, so we'd have to have new abutments and whole new structures. But as we keep alluding to, the ground around there is not very good at all. So they'd need large foundations and significant access, both of land and track access in order to build. The current plan, or the proposal when we were going through this, was to install the foundations one Christmas, come back the following Christmas to put the bridge in. And that gives you an idea of the sort of scale and size of the foundations, and then also how much longer possession we need to put the bridge in. Also in the core section, another one of our major constraints was a level crossing called Kiln Lane. It's a private road that currently goes to a dead-end cul-de-sac with an industrial estate on it. And all in the top right picture, you can see all these yellow, orangey areas. That's all SSSI, Site of Special Scientific Interest. And it's a high-risk level crossing, as it's an automatic half barrier, popular for public right-of-way. And this also creates double blocking issues as the train, as freight trains can't be stopped on the protecting signals for Ely North Junction, as they would sit back across this level crossing. So they have to be double blocked, one block back, again, constraining the capacity. So we had some consulted proposals about closing level crossing and possible buyout of the industrial buildings. But this would involve us having to restore the public right of way over the railway, either by a footbridge or by a road bridge if we need to maintain vehicular access. And as you saw, there's not much space to put it if you're not going to go into a SSSI. So that would lead to some consent issues. And it's interventions are provisional. I shall caveat pending further consultation. Notice the writing in red.
Interestingly, we didn't consult on the option that's on the table.
No.
We consulted on, do you want a big bridge or a small bridge? And they said, no, we want to buy out the land.
Pass on to Peter to talk about a lovely tractor.
So this is the layout that was left for us in the 1992 renewals when the wires went up. At the moment, there are, oh no, sorry, in the desired train service spec, this is a slightly different train service spec, so ignore the 11. In the desired train service spec, that particular stretch of track gets very, very heavily used in red there. And essentially, we need parallel moves. For those of you that don't know the area, this is where the line diverges to Peterborough, Kings Lynn and Norwich. Norwich was the original route, and it's now very much the minor partner of the junction. Then Peterborough was built, and then Kings Lynn was built. And over the years, it's all kind of got kind of shunted around to recognise the actual flow of traffic. There's absolutely nowhere to lose a freight train. So not only have we got very limited capacity at Ely Station, you've got nowhere to lose a freight train up here. So once that freight train is in the pipe, it's got to pop out at the far ends. We mentioned about the double blocking of Kiln Lane, which is the grey crossing on the left, but we've also got double blocking of the 3 level crossings immediately to the north. So essentially, if you don't have best part of 3 proceed signals in a row, you're stood, and it's really, really hard to manage, especially even for passenger trains, but the same applies for freight. And we talked about the single lead junction. So this is what it looks like in plan view. Like to draw your attention, the obvious road jumps out that's running that's running from middle top to bottom right. The road that's not so obvious, but is actually just as important, runs from middle bottom to middle right. These act as a crossroads, and actually the primary flow up here is up from the south of Ely and then left to massive new housing development that Ely has decided to put in and not spend any money on the level crossings. So the junction itself is defined as there. This ties pretty much into the previous Kiln Lane image that we saw. Peterborough, Kings Lynn and Norwich. There's also Ely West Curve. So there is a way that we could take a Norwich train to Peterborough without, or vice versa, without going via Ely. And they did used to, but now Ely has grown as a hub, and so we now divert trains in, which is why we've got that bounce back move. None of you are local, so you probably wouldn't make the differential here. Mr. Potter owns Papworth sidings, so it's right there, and you can see it's had significant new investment. It's warm storage for recently unrequired passenger stock.
And part of the project requirements is to maintain access to Potter's Yard, Papworth sidings for one train a day in each direction, and access in both the up and down direction. So adding further constraints to the layout of the junction.
So it's also a cement works for the local area. So it's just a bit of everything. And again, there's that pesky river. I've just ringed the level crossings. So you can see just on that image alone, there are 7 level crossings. There's a B road where you've got the 3 Queen Adelaide ones in a row. You've then got Kiln Lane off to the left, and then you've got private user worked, and then 2 public footpath crossings. That's also user worked as well. So it's just crossings everywhere out here. And this is an example of just how flat everything is. So they don't just have flat land, they build flat buildings as well. But you can just about see in the middle of the screen the wigwags and the barriers for the next crossing along. They're 130 metres apart. So we have to be very careful that we don't sort the rail problems out, but actually make a road problem. So we've got a number of options. ENJ0, leave the junction alone, basically just fix the level crossings, manage the risk at the level crossings of the additional traffic. We can do some signalling tweaks to also remove some of the double blocking by carefully repositioning signals and putting some clever logic in the interlocking. We can deliver 11 trains an hour, but it's pretty sweaty. So then we went a bit further. So ENJ1 basically is well, all of these are a full rebuild of the level crossing with of the junction with the level crossings upgraded. The difference between them, ENJ1 is essentially a double junction based solution. ENJ2 was a laddered out solution, and ENJ-SE is ENJ1 but with different signalling treatments on it. Again, we can remove most of the double blocking controls. We really could do with a bypass to support this, to take some of the traffic away from the level crossings, primarily the Peterborough level crossing, because if you remember from the trains per hour diagram, the Peterborough level crossing is closed a lot, and we're talking about kind of, I think the number that went in the consultation was about 27 minutes an hour closure, if all of the freight trains materialise in that given hour. But it's pretty good. You can actually deliver a significantly enhanced train service over that layout. We did have some slightly novel solutions. So if you rip the Peterborough line level crossing out and then build a diversionary route, you've got new alignment 4 option. It puts more trains over the King's Lynn line level crossing, which means that you can remove. So you still need to upgrade the level crossings. It takes most of the double blocking away, but you do need a bypass because that level crossing will be closed about 38 minutes in the hour, and that wasn't viewed as acceptable. This is a B road with about 5,000 vehicles a day on it. And actually you get lower capacity than if you do just a double junction version, because you pulled the junction apart by a signal section, and so actually it works worse. Flip the hand of it, so we've got a new alignment 5.1, 5.2. Essentially, it's exactly the same conclusion. Very easy to build because there's no gradients to think about. Everything's flat as a pancake. But the scale of the earthwork, yeah, you're into really quite complex. I think the preferred solution was the inclined deep mixing piles. It's a significant intervention to get down there. That one is absolutely not double blocked anymore. So that's really powerful. So you now don't have any double blocking in the area. So the signalling system can really deliver the headways that it needs to, but you've got to build a bypass. So if we're going to do a bypass, what are we going to do? So we came up with 12 aerial bypass options. Principally, you can go north or south of the village. You can go short or long. Various combinations of the 2 or of the 4 options. We also looked at one, we called it a cutoff, which tries to attract traffic away without eliminating traffic. It tries to give a desirable route for an alternative. So these are the consultation images. So this is the long north option. So we've closed the Peterborough line level crossing, rebuilt it with an on-site ramped footbridge, and then a long bypass looping over the fields to the north. It's about just over 2 kilometres long. So these are all, some of this is PWI specific, please. This is all public domain. You can go on the Ely consultation website and find these if you want. Flip it. This is the long south bypass. Again with the inline footbridge. There's a short south bypass. So we actually use the Norwich line level crossing, but then as we get to the Kings Lynn line, we suddenly divert around it. And it's the shortest single intervention. And this is the cutoff. So this is actually longer than that bypass. And what we're trying to do here is attract traffic from Prickwillow out to the east to go to the south of Ely, and onto the strategic road network. So this, you can't close level crossings with this, or you can't close the highway level crossings with this, but it does reduce their use slightly. So feedback from the consultation is that the leading option, not the preferred option, the currently leading option, is the standard track layout with slightly different signalling impact, with the southeast cutoff that I just showed you just a second ago. It's the smallest land take. It's also nothing's in the air. So that's quite a key driver, because the land is so flat. As soon as you put something on stilts, it becomes one of the most visible things in the area.
There's lots of protected views of Ely Cathedral.
So we can deliver, the edit says required capacity. We can deliver 14 trains now with this. And if you wanted to send more trains to Norwich and Kings Lynn, we can go even further than that. It could be upgraded with a bypass in the future. So you could build a bypass and the cutoff. So we tried to leave combo options available, if not explicitly assessed. I mentioned it's at grade. There's also a footpath that we need to divert to remove the double blocking. And again, that's at grade. And it was the best, it received the most feedback, or the best or most preferred feedback, which is unsurprising, really. But yeah, the sponsors caveats. So up till now, it's been quite track focused or structures focused. But this is a programme, and we really need to recognise that that the level crossings are a really, really critical thing here. So I'll hand over to James to take you through the local area.
So to manage the level crossings in the area, we developed a strategy of how we were going to do it. Now, originally going from grip 2 into grip 3, called in old money, we reviewed each level crossing and established that as the risk was going up, we looked at interventions at all of them. And it was quickly realised that that was unaffordable. So we had to develop a strategy in order to work out how we would manage the risk. So as we've said a few times, there's a greater than 180 level crossings. It's growing in the affected area, all with increased risk. We had an initial feasibility based on the intervention at all level crossings. Then we had that evolved into a strategy that had interventions based on 6 criteria, and this was agreed with level crossing managers and the station review panel. And then this was further developed into a strategy, but using a benefit cost ratio, which took proposed options, got an estimate, and then worked out the benefit of the risk eliminated by the options versus the cost of that to try and get a positive, well, above 1 ratio of the BCR ratio. So yes, there's some critical issues, uses, misuse, technology, and especially as you saw with Queen Adelaide, there was the barrier downtime and the highway impacts. This was also a big impact in March as well. And the assumption following the BCR work was that at 44 locations we'll need some sort of intervention. And that intervention ranges from miniature stoplights all the way to a closure with a new bridge. And all of those options were evaluated. One key example is Stony level crossing. It's a hand-operated gates on a level crossing with a nice little underpass on a stony bridge. It's the bane of my life at the moment now. I'm the structures engineer for the area. I keep getting phone calls from control about vans keep hitting it.
It's got a 2 metre
2 metre headroom.
headroom on it, and so that's why you get vans ripping themselves apart.
This is one of the more impressive collisions. So Stony solution was MCB OD to remove the need for manual closure of the gate barriers. There was anecdotal evidence that sometimes the barriers can be closed for a long time if the signaller knows there's going to be a train along in a while, but not that instantly. There's also quite a lot of abuse for the signaller there if the level crossing is closed. So it removes a lot of risks in that way and improves capacity. And then at the moment, the priority road layout directs people towards the underpass. So if by the simple repainting of some white lines, you can sort of direct people to the level crossing rather than the underpass, and that will make my life nicer.
So we're thinking of your Tesco delivery driver, first time on that road, blindly follows the white lines and just rips the box off the back. And so something as simple as rehandling the roads starts to manage that risk.
And that's the key word. It's all about managing the risk on all of these level crossings. There's also this possible downgrade of the underpass to just a cycle path, just to prevent that rat run, but allow the pedestrians to use it.
I think that ended up as the preferred solution for feedback. People would rather that we automated the crossing and made it the only route. Which is really interesting. You think, no, we want the continuously available one, but no.
I think people the local residents for that one, I think sort of the local pub owner said he's fed up with people queuing for the level crossing, so they just want something to be done, pumping fumes into their pub garden. So we used the level crossing option selection tool, which used this safety based quantification. You can see lots of basically whole life cost of the intervention versus the fatality weighted index risk cost change against someone's life, and a disproportionate gross disproportionately factor, which was added as well, and this meant that this is how we arrived at the figure of 44. I think it was for the whole scheme. I think we do this bit.
It's also worth pointing out of the 44 that remains, typically they were smaller interventions at the 44. So rather than going for a bypass and a closure, it tended to be an MCBOD upgrade rather than the bypass, because a £4 million MCBOD upgrade versus a 10 to 12 million pound bypass wins every time, even when considering the risk, even because there is a residual risk with that one, it still wins. Over the whole scheme, so you can do all of these changes, but you actually need to then be able to run a train service over it. So we had to also do a headway assessment. Using Stony as an example, when the signaller has closed the gates, he then goes into the box, and here's a he goes into the box, presses a button, and then it clears the signal. And so if somebody's out there shouting, "Let me open the gates," he has to cancel the signal and go and open them. So that there's a bit of to and fro. It's just, he's sitting on a 7-minute headway, which is crazy, absolutely crazy, given that the planning headway on the route is 4 minutes. But we know that the technical headway is 7 minutes, so it doesn't work. At the moment, the timetable isn't run hard enough that it's an issue, but in the future it will be. So I'm surprised I didn't edit these slides out, actually. So in the longer term, a 4-minute planning headway is needed, and to do that, you either need lots of additional signals, and I think we worked out it was about 9 in each direction, or you just need to go modern and put ETCS in. It would it's absolutely perfect route for ETCS, really.
Currently semaphore signal.
Yeah, and the semaphore signals are falling down. Like they're 1910, I think they are, and the posts are rusted. So there's got climbing bands on them. So there's a project out there at the moment moving them back 5 meters and making them colour light signals. But even then, the next batch of failures are only 10 years away, so they need to get on and fund this. We need to do the headway interventions before we can really turn the wick up on the train service. So if you do the intervention, excluding the headways, you can deliver 10 trains an hour. But like I said, it's got bags of scope left to actually run up to 14 trains an hour, but you need to fix your headways. So we mentioned earlier that this is a Transport and Works Act order. So stage 1 consultation was done a couple of years ago, and then the stage 2 consultation was done as part of this contract. I sat on about 40 landowner calls, and it's really interesting. I've never done it before, but actually sitting there saying, we may need to buy your house is a very strange thing. And I always got the pleasure as well. Simon was just like, go on, Peter, you do it. We also went to Queen Adelaide Village Hall, which was the building I was saying was shaking as the tractors and lorries go past. Stage 2 consultations in 3 parts. So we consulted about the station, we consulted about the North Junction, and we were going to consult about everything else. And that was the moment that we go to where we are today. So the work that we've done, and there've been a number of engineering managers, I was just the final one of 3. So we've remodelled 2 major junctions, and they are major for the area. We came up with solutions for about 100 and something level crossings, but 44 of them have been selected. We've looked at what headway reductions are achievable. They're currently not in scope. And then we supported Network Rail with the outline business case and program management support. So, for instance, the common safety method application was a WSP person seconded to work for James to deliver. Yeah. So where are we today? So that OBC, after a number of rewrites, was submitted in March 22, which was its original programme. Even with the loss of passenger service and the rebound curve not being or being factored in, we're still scoring a huge BCR. Passengers are, roughly speaking, passengers are about half the BCR, freight's about half the BCR. So you do need both to be a good scheme. Not having COVID would have made it a great scheme. So where are we really? For those of you not familiar with the rail network enhancement pipeline, it's DfT's pipeline for working out how they're going to choose to fund rail network enhancements. And essentially, we're in the queue. Speaking candidly, it was too far south at the time that the OBC went in. Clearly, the leadership of the country has changed, and who knows where we will be in a few months' time. The project effectively hasn't quite finished Grip 3. There's one we've got lots of options floating at the moment, and there needs to be one exercise to put them all together and validate that the chosen option works, but we can't choose the option until we finish consultation formally. So there's a little bit more to do. 8 minutes, Mr. Meads. That's no problem. So what questions have come through then?
Can you see them on your screen?
Not easily.
Great, so if you can pick one, well, in the room. Questions? What sort of possession requirement do you see for the construction?
what would I like or what would I get? It's key freight route, and so there are diversionary routes available, but you don't really want to be sending freight via the North London line where you can help it. So we were really trying to deliver what we could within 2 weekend possessions, basically. But then you've got the trade-off of how many weekends in a row do you really need compared with a big bang blockade. So we hadn't got to that level of detail.
It's complicated by, so you've got Middleton Yard. What's one next to March? No, Whitemore next to March, the depot for NR. And the only way out of that is through Ely or onto the Great East Coast Main Line. So in order to get possessions, you need to line it up with everything else and where engineering train's going to end up. So it's quite, yeah, it's tricky.
The original scheme was Felixstowe and Nuneaton, wasn't it? What was the Peterborough to Nuneaton portion progressed? That was in terms of 96 boxes.
So there's a tender active at the moment to do the Leicester to Nuneaton chunk of that, and it's got my name down. Should we win? Progressing further north, I'll be working in Scotland before I know it. It's being looked at in chunks, essentially, Ken. This is the Anglia chunk,
yes,
and then there'll be an east coast and chunk, and then, like I say, the middle hub is picking up the everything from Melton this way. Oh, sorry, Melton west.
Yes. I was a little surprised that there wasn't a little bit more emphasis on Stansted airports, passenger traffic. That seems to be a major passenger path for passengers to Stansted from the north. You hear congestion on that route. Is there any provision for more future traffic into Stansted through the scheme?
So what we had on that particular slide was an example of how 10 trains an hour could be divided. They are the 10 trains an hour that had the benefits models of them. What we didn't include is services that start at Cambridge. And don't forget, Cambridge is due a major upgrade as well, both as part of Cambridge South, Cambridge just generally needing an upgrade, and then East West Rail coming in as well. So there's that's not, we're not just saying there will be 2 trains an hour to Stansted. There will be good interchanges. I realise an interchange carries its benefit, but and this is, as every project you've probably ever worked on, the timetable that gets executed is never the timetable that goes into the development plan. So we can play tunes on this layout. You can do what you want, really. The only thing that you can't really turn up much at the moment is the Kings Lynn line, because it's got big chunks of single track. But then the line over to Norwich, with a couple of tactical signalling interventions, that could take a much bigger train service if there was the demand for it.
I have a question for Peter Hannawell. I checked what speed enhancements will be delivered over the bridges through the station and the remodeled junctions.
So the speed that the layout gave was it would be 50 miles an hour through the whole core. So, and that would have been no heavy axle weight restrictions either. So everything could go through at 50.
So we did what we've done on other projects, and we actually looked at a slightly lower normalized speed rather than absolutely springing the last little bit of performance out of it. So Ely North Junction, the one that's on the screen at the moment, we basically designed one long straight from the south towards Kings Lynn, and then had the turnout route going to Peterborough and the turnout route going to to Norwich. Explicitly, we could have gone much faster towards Kings Lynn, but actually the benefit of it is, in a pre-ETCS world, the benefit of it is you just get a green and a feather. just telling you where you're going. Obviously, we put controls in, so if you're an electric train, you don't end up beached up towards Chetisham or whatever. But yeah, it's actually better to run at a consistent 50 than odds and sods of other speeds. We tried to make everything we could within 10 miles an hour of line speed as well. Unfortunately, the freight loops didn't make that cut without building the additional span over Cutter Bridge or the additional track bed over Cutter Bridge. So
really surprised, probably my naivety about understanding these enhancement considerations on something of scale, but I suppose for a railway scheme, I'm surprised how much bypasses were necessary to deliver that sort of enhancement that you're looking for. Was it something that you were given the encouragement of straight away to just look at a blank sheet of better infrastructure in the area, or was it just something you realised very quickly would be necessary to deliver?
I think it's been recognised for a long time. You can't sort out the rail layout up there without doing something because of the topography of it, and also just how much they interact. Impacts the level crossings. One major concern with those level crossings was queuing and blocking back off cars through to the next level crossing onto the. It's one of the major risks there, especially at the moment with them being AHVs. So there's no obstacle. That word, obstacle. Obstacle detection. That one on the level crossings at the moment. So there is a risk of stranded cars there at the moment.
Yeah. So if that wigwag starts flashing and beeping at you, 27 seconds later, a train will be there, whether they're still there or not. Whereas with an MCB of a various flavour, at least the signal can't be cleared when you're obstructing the crossing. Actually, that's quite a good question, Paul. Things changed a lot over the time. So originally, the original question before you were on it and before I was on it was, don't do the roads. And Cambridgeshire County Council came along and said, no, you need to fix the road when you do this. And we want you to do fix it once solution, not come back and keep patching and mending the solution. So that was actually a subcontract. Then, if you remember, that we then came along and designed the various road bypass options. They then went into GRIP 3, and during GRIP 3, Cambridgeshire's stance softened, not fully softened, but it softened, and the project team clearly didn't want to build a road. So we're actually kind of back to square one, where we're actually just going to live with the highway risk. The chance of driving through the village and not stopping at a level crossing in the 11 trains an hour scenario, I haven't modelled it in the 10, but the 11 trains an hour scenario is 0, because of the way because you've got to get the 11 trains an hour flowing over the junction, which is actually 22 trains an hour if you think about it, because that's in each direction. To get them flowing over the junction nicely, inevitably, when the Peterborough line is closed, the Kings Lynn line barrier is open, and then you close the Kings Lynn line barrier, and then the Peterborough line opens, and so on. So yeah, if you were to drive through the village, 0 chance of going through. So I think a bypass in the long term, if you want to get to the 14 trains an hour and the all-day heavy freight, probably out of bypass scenario. But in an interim kind of 10, 15, 25 years type solution, you don't need a bypass anymore. It's tolerable. I wouldn't say it's good, but it's tolerable. We have turned the signalling up to 11 on it. Literally every control we could put on it, we have. Every braking distance is pretty much optimized. And that's got barrier downtime down to, I think cumulatively at the moment, it's 45 minutes across of that order across the village. But it's a good question, actually. Yeah, it's really not. It's really interesting to kind of feel the political winds changing on a scheme like this. in terms of is road the answer? Is road not the answer? Mobility is mobility everything? Yeah. I haven't got time for that conversation.
Conscious because there's another more detailed question for Peter, which unfortunately people won't get time to ask a specific question, won't get time to answer, but hopefully just asking particular information about, which hopefully will be in the public consultation. But right, so
Scott there. So thank you very much indeed, Peter and James, for a really interesting off-region presentation, and fascinating to hear about a scheme that's got so many interfaces, which at first glance you'd have thought sort of the track remodelling of it is fairly straightforward, but when, as you bring the level crossings in, you explain very clearly how, you know, there's so much more that the project needs to take into account. So absolutely fascinating. And despite that, still having a business, what does BRC stand for?
Benefit cost ratio.
Benefit cost ratio, thank you very much, of 4 is quite remarkable when you think about the amount of infrastructure that there is here and the number of trains you're trying to get through. So fabulous presentation. Thanks very much for giving it, and a round of applause, please. Those of you who are here in person,